welcome everybody, and thanks for joining. I thought, this topic came up because I've been doing a lot of sensei reviews over the last year or so, and one thing we seem to not always get right is, our part in the whole elevator piece of the design of the structural piece. So I thought, well, maybe we'll talk about that. We have some, we have some really good typical details. We have all the things that we normally put in our drawings, but I don't think we always pay attention to these things first. And so I thought maybe we'd talk a little bit about, how these systems work. And then I think once you understand how the systems work, then it's really clear, what our role is and what we need to do, and how we roll about that. So there we go. So here's our agenda. Talk a little bit about elevator types because they're not all the same. In fact, I'm going to just talk about the two most common types, and there's 10, 15 different variations of all those. What are some of the code requirements, things we need to know about? What's our role in this whole process? And then elevator guide rail support details, which we have some very good typical details, and we don't really never need to change them really unless we have a very unusual elevator. Pit details, questions, and then kind of, the ins and outs of the ups and downs of, what our process is for this. So, and what we should have in our drawings and what's not really our responsibility. So, I mean, there's two basic types of elevators, right? There's the traction elevator, and there's a hydraulic elevator. The traction is it's the kind of system you typically see in high-rise buildings or taller buildings. I think the limit is usually, hydraulics are very good for up to about 4 stories. Above 6 stories, you probably want a traction elevator because they have, better capacity, they move faster. The difference is the hydraulics. If you can see on the one on the right, there's a hydraulic cylinder that typically will go down, be buried down in the ground, and the elevator cab just rises in and out of that hydraulic cylinder. So the cylinder that goes down into the ground is typically as tall as the elevator goes, 2 stories, 3 stories, maybe 4 stories. They also have holeless too, which has a hydraulic, piston on the inside of the shaft that'll lift the cab up and down. In the traction elevators, they're really driven off from the top. The cab is suspended by cables, and there's a counterweight that goes up and down counter to the cab, and there's some very heavy machinery, or heavy duty machinery up on top in the elevator machine room. Typically in a traction elevator, all the elevator machine stuff is on the roof or up at somewhere near that, and it lifts the elevator up and down. So if you're doing a traction elevator, you need to coordinate pretty early on for the machine room floor, because there's a lot of openings for stuff to drop through, and 2, the loads from the equipment there can be very high. So you need to pay a lot of attention to that. So if you have one of those, get involved early. So really, our piece of this is, we design the pit, we show the pit, we do all the reinforcing for the pit and all that sort of stuff. We coordinate with the architect for the size. And then I don't know if you can see my cursor or not, but the elevator guide rails themselves, which are these things that the elevator runs up and down on vertically, they will be laterally supported by our guide rail supports. And we're really the person responsible for the guide rail supports and attachment to the structure. The elevator guys pick up, you'll see these little brackets, going along so often. And typically we'll space those 4 to 6 feet, up our guide rail supports. So they don't really run floor to floor, although they could use a heavier rail and span floor to floor. The elevator guys typically don't. Apparently it doesn't work so well for them. So that's how that works. So yeah, we will be responsible for the guide rail supports. Code requirements, there's obviously there's stuff in the CBC or in the IBC. The A chapters have the most definitive guidelines for elevator guide rail design. And maybe back up a little bit. And the reason that became so prominent in the 71 Silmar earthquake, prior to that, elevators weren't really engineered. They were just installed by vendors and manufacturers, and they weren't seismically designed. They all failed horribly in hospitals. So, and they wouldn't work. And that was, obviously that's quite a problem in a hospital facility, you know, after an earthquake where they're very busy and they need capacity and they don't have it. So Oshpod got very involved in the design of elevators and the structural support of them. And, you know, even to the point where they wanted to get into the elevator design, into the actual design of the elevator and kind of the qualification, more like the stuff they're doing now with the mechanical equipment, but they were doing it from a design perspective. And you know, I think somewhere in the 70s, the elevator guy said, you know, we don't sell that many elevators to hospitals in California, so we're not going to sell them anymore in California hospitals. So Oshpod kind of backed off, and they just started looking at the rails and the guide rail supports that we do. They left the elevator cab and all that stuff alone, kind of as a black box, like we typically would for a mechanical unit or something like that. So, so our basic building codes, the CBC and of course the IBC too, they'll reference ASCE 7. They'll also reference the ASME A17.1, which has a lot of criteria for the design of elevators. Some of it structural, a lot of it really not so much structural, but there's and all of these documents are in our library. So if you're interested, go, open up your library drive and have a look in there and pour through all the stuff in there. It's good reading when you can't sleep. So that's all I can say about that. Here's our code requirements, in the CBC chapters. In ASME, guide rail support deflection, this is what we really need to remember. Our systems are limited to a 1/8 inch deflection under operational loading, and they're limited to a 1/4 inch under seismic loading. The seismic loading will always control in a seismic area, because the operational loads are relatively small and the seismic loads are relatively large. They're, so if they're more than twice the operational loads, then the seismic is going to govern. This section here, 13.6.11.1.1, talks about the distribution of the loads. And I got a little graphic, I think, on the next slide that shows how that all works. But, it gives you the weight to include, including a part of the elevator capacity. So this is how that works. Oh, look who's in the elevator preparing for their speech tonight. So we basically, the mass we use for the elevator is the weight of the cab and 40% of the rated capacity, which I think the more common elevators now are the 3,500 pounds elevators. Seem to be getting bigger because they all tend to need to be gurney capacity now in a lot of places. So you can get a gurney in and get a gurney out and get someone, out of a building that needs help. And typically early on in the project, we don't know what the cab weighs because an elevator vendor hasn't been selected, or they're non-responsive, or we don't have any coordination capability with them. But if the architect is speccing a 3,500 elevator, 3,500 pound capacity elevator, you can bet that the elevator cab itself is going to weigh about 3,500 pounds. They always have, maybe they always will. And then the code asks us to distribute, we calculate the seismic force, which is the cab weight plus 40% of the rated capacity times the F sub P force. And then we put 1/3 of that, at the top, and we put 2/3 of that at the bottom. And then we come up with our forces to our guide rail support posts. So typically, when the cab is moving around, you could get these two forces somewhere along the span between floors, but the controlling force is always when you put the bottom reaction in the middle of the floor. So if you have a 14-foot floor to floor, your load is going to be at 7 feet. Pretty simple, right? There's also a code requirement that F sub P can be no less than 0.5 G. So that's been around for a long time. So that part is fairly simple, right? In fact, all of this is fairly simple.
Hey, Jeff, this is Pete. For the rails on the previous one, shouldn't it be for the 2 rails if the load is perpendicular to the rails, but they're not physically connected. So it's either pushing on one or pushing on the other. So it depends on the direction.
Well, yeah, no, you're right. Yeah, you're right.
Just so people aren't taking this as Bible, because there's.
Yeah, no, you're right. I screwed that up. That would be, sorry, that would be the F1R1, F1, F2, R2 load. Sorry, that half should come out of there. I'll distribute this later. I had this fact check too. I was doing it too fast last night. Yeah, you're right. If it's going perpendicular rail, only one of the rails sees the load. If it's going perpendicular to the face of the cab, it's going to engage the two rails, and we'll look at that later in the elevator guys submittal stuff. I have a little slide of that. Good catch, Pete. Thank you. That's why I don't really do engineering calculations anymore. So what's our role? The elevator brackets and rails are typically a vendor supplied deferred approval. You know, ideally you'd have them, you know, all when you go to the building department, but you know, elevator companies are probably the least responsive people in the construction industry. And that's, oops, what did I do? That's true across the board. They're all bad. So you never have that. So, and typically the contractor will wait to buy out the elevator to the last minute, and then they'll come and they'll provide their stuff, and they'll get a separate permit as a deferred approval. And it's pretty much always that way with DSA and OSHPD as well. So we design, you know, essentially the hoist way. The guide rail support columns, separator beams, and the hoist beam. And then when, you know, they get around to getting their submittal and the deferred approval item, we'll review the elevator vendor's deferred submittal for general conformance with our criteria. Hopefully their, you know, their reactions are somewhat near what we've selected or based our guide rails on. Hey, we have this really good checklist for elevators in our library. If you look through our library, you'll see this. And this is really the piece we're responsible for. List weight of car and rated capacity, blah, 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 right? So that's all the stuff we just talked about. Distribution of load, third to top, 2/3 to the bottom. Structural framing support for guide rails, that's us, right? 0.25 inches deflection criteria for seismic. And then here I put a little reference to where you can find that document. There's a lot more in that document, but it's really related to the elevator design, not so much to our piece. So feel free to go read that. Again, when you can't fall asleep at night, it's really good stuff. But if you get involved in DSA or OSHPD stuff, you'll get more, you get more involved in all these particulars of this stuff. Here's kind of some of our typical details. This is a project we did not too long ago. It's just completed. You know, typically I'll use 2 guide rail supports. This was kind of a funky elevator, so we actually did have the chance to coordinate with the elevator guy, and their guide rails were quite far apart on the outside of the elevator, and then we just had a large vertical guide rail support on the separator beam. So the separator beam, and that's a beam that it'll go through the pit and it'll go across every floor. It's really just a place for the guide rail support post to land when you have multiple elevators, right? So we have an elevator in this box, and then one in this box. So, and we need to have a guide, and they'll each have rails on either side. So we'll design that for the same forces as well. And here's on the right is our typical elevator guide rail support system details for a steel building. For concrete or masonry elevator enclosure, we don't really worry about that at all, because they can just attach their rails to the walls. And the concrete walls or masonry wall is plenty stiff enough to provide the 1/4 inch deflection and meet all the strength criteria. So we don't really spend a lot of time looking at that. We'll still need a hoist beam, and a hoist beam goes up at the very top of the shaft, and they only use that to actually run a chain over that when they're installing the elevator, and they use it to lift the cab into place. So as Veronica says, it's kind of a one-time use thing, but make sure this is typically designed for about a 5,000 pound load. That's kind of the default. So they can pull the cab into place. And it is laterally unsupported. So I usually use a pretty hefty section, like an 8x18, something that's got a wide flange that's very stable and can span the pit without being laterally supported. It's compression flange. So that's what I like to do. And as a default, I pretty much always like to use 2 elevator guide rail supports, especially early on, unless we get more definitive information later that we can actually design something comfortably. And the reason I do that is because a lot of times I said that the elevator isn't picked until later, and then they come up with a different elevator. We had this happen about 15 years ago. This was actually the owner wanted to change out elevators, so we had to do something different. We had guide rail support posts, programmed into our drawings already, and they came up with a Otis Gen 2, I think it was, had completely different guide rails. So we had to trash our guide rail supports and go with much heavier ones. And I think it was about $100,000 change. At some point they're looking at us going, what the heck? And we're going, well, you changed elevators, whole different system. So I always like to be on the conservative side when I'm picking that stuff early on, because, I think when I reviewed that change order, I came to the conclusion when they bid the original elevator guide rail supports, the steel cost about $2 a pound, and the ad service when they made the change, it was about $10 a pound. So a premium of about 5 times, because it was a change order, not because it was originally bid. So always be attentive and make sure that these things are in your drawings when you go to bid. And as long as you have all your elevator details in there, you should be pretty good. But make sure that they're appropriate and that they work for the building you have. Pit details, these are right out of our standard drawing template. We still say 4-foot max on that. We might want to think revisiting that, because I don't know, we're seeing deeper pits now. The pit used to be limited to 4 feet because at 4 feet you didn't have to have a ladder down into it, but I don't think the elevator people care so much about that anymore. And for some reason, the whole industry has moved. We're seeing 5 feet, 5'6" pits now are fairly common. So maybe we think about that. And I don't think it matters in really our pit design, because an 8-inch wall, it pretty much spans horizontally anyway. So that'll still work. And then here's our separator beam detail. Typically we'll use an HSS section, a rectangle, an 8x6, usually works pretty nicely. And note that these are allowed to vertically slip too, because we don't want them to turn into building columns. They're just lateral support elements only. So hopefully our details are good. They've been used a lot, and they've been very successful. So, only alter them when you really think you need to, and you know exactly what you're doing, and you've put some critical thinking into it. And here's kind of the stuff we'll get from the elevator vendor at some point, the rail forces. As we said, here's the F1 and the F2, or typically they'll call these R1 and R2. I don't know why this vendor has a different nomenclature, but I would say 90% of the vendors will have that R1 and R2. But the F1 is perpendicular to the rail. This is actually an omega rail, which is a little unusual. More often than not, you'll just use a regular, T rail that's in the AIC and in the steel book. But here you can see our operating loads about, a little less than 700 pounds, 688. The seismic loads are in the couple thousand-pound load. These guys, they calculated different rail forces at each floor based on the height of the building. They're allowed to do that. Typically, I would only do it once, and I'd use the highest point of the building. But if the floor-to-floor heights vary, maybe that's an advantageous thing to do. It probably is for them. I don't know if we want to get to that level of detail, but that's how that all works. Yeah. And this is the more typical rail that you would see, and this is just a rail section straight out of the AISC. The 11-pound per foot rail is the most common. And note, if you're doing work in DSA in Oakland, for some reason they have a policy, they won't allow people to use anything less than a 15-pound per foot rail. It's a little stiffer, a little heavier, obviously, a little bit more expensive. But typically we'll see very detailed calcs for the rails, for the brackets, for all the attachment. There's these elevator clips that go on there, the guide brackets. And then here up at the top are the different configurations that, you know, they have these all in a bunch of standard details, but this is for, you know, concrete wall, masonry wall, you know, if you're attaching to, I don't know what exactly this one is, but the single tube, a double tube, and then if you got something else, it, you know, they have kind of all those conditions covered, how they will attach their brackets to our support system. So be aware of that. We do have in our reference library, there's also a sample calculation that we retained, just so you can see what all those look like if anybody's interested. It's kind of an older one, but it's still legitimate. So Josh and the engineering support team, good job for capturing all that stuff and storing it for future generations to use. Hope it's useful. But if you ever need that, you know, feel free to browse through that. There's a lot of good stuff in there. And here's the one I like typically with two support posts. And like I said, my default starting size is always an HSS 6x6x3/8, and I like to use 2 of them because I know it's going to work for like 90% of the time. And if we're forced into something else or we have better information, obviously we can do something, you know, a little bit more refined if we need to. But, you know, given the cost of the change order steel versus the bid steel, I always like to be on the comfortable side for these. Because honestly, these things cost nothing, you know, versus the steel package. But when, you know, when you get a $100,000 ad, you don't forget that quickly. So basically, we're responsible for the guide rail support posts, and everything outboard of that, the brackets and the rail and all that stuff, is the elevator vendor. That's it. I like this idea. So, questions, thoughts, comments? Is everybody still there? Still awake?
Hey Jeff, this is Pete. It's been a while since I've done some of the elevator equipment room, but there's some very stringent deflection criteria for elevator machine? It's like L over 1666 is in my head for elevator equipment.
Yes, yeah, that's true. That's in the ASME I learned last night. Yes, so you need to pay attention to that too. I didn't really get too into that. And also, we don't see that many traction elevators, so.
Correct.
But you're right. It's very it's rather large, or rather stringent criteria.
Jeff.
Yeah.
For any of these traction elevators, you're also going to have a set of guide rails for the counterweights. So
yes.
For each elevator, you'll have 2 sets.
Right. And we will typically provide the guide rails for those. They're the guide rail supports, not the actual rails, because the rails come with the counterweights. And obviously the counterweights are pretty heavy because they'll balance the weight of the car, so they're not light. But they don't, you know, they're loaded at a different time than the cab load, so they don't combine. Is that it? More questions? All right, everybody's asleep on their lunch break. So thanks, Zach. Yeah. I think we're good. Unless anybody
I have a question. Jeff, this is the punch. Hey, we were looking at the traction elevators earlier, right? So if you could go back to that slide again, I think it's the second slide or something.
Yes, sir.
So the machine, it sits at the top of the elevator, so we do have to design our floors for all that machine load.
We do.
And that's where Pete was mentioning the deflection criteria.
Yeah, typically you would have a very thick concrete slab there, has been my experience. And like I said, because each of those pieces of equipment, usually they drop something down into the shaft. So they have a bunch of holes and they never line up like it's a straight perfect beam thing. So, and the deflection criteria is pretty large, and the reactions from those things, not so much for the weight of the machines, but the reactions for the operations are very large. So, you want to carefully coordinate that. Another thing to note, this doesn't really involve us so much, but the fire construction requirements for a machine room and a traction elevator are extremely challenging, or they're very tight because you don't want a fire in there.
So what would be your recommendation for design of those rooms while we wait for the actual machine load, like a pound a square foot that you suggest we use?
Oh, I mean, it could be 300 to 500 pounds a square foot if you're converting it to a uniform load.
Okay.
I'm trying to think of the ones I've done in concrete buildings. I think we've started with like 10-inch slab or something like that. They don't span very far, but you want them to be very stiff. Yep.
Okay.
Hey, Jeff, this is Veronica. Something else that I have noticed is where we place our rails or halo steel around this thing as well. Because you were talking about the fire requirements, you do want to look at the architect's detail to see what he's doing. So, because they're going to kind of look at our drawings to see where to place those elements. And I try and drive them to look at the architect stuff, but you do want to coordinate that with what you're trying to do with your wall and your slab and how that's working. It's not just throw those elements on your plan. You have to be thinking about where he's going to need those to be, because it just seems like for us, they always mess this area up. There's just not good coordination.
No, Veronica's got a good point. I mean, typically you want them to do the shaft with shaft studs because they are a rated enclosure. So they need to have their own fire rating, and then the architect is going to have his own fire resistive assembly details that will meet whatever UL rating that they need. And our stuff all has to be within that and be coordinated. Hopefully it'll all work, but you do need to pay some attention to it because they may or they may not.
Sorry, we've done 4 elevators in the last year, and thinking about it, every single one of them have required field adjustment because they don't pick the elevator until, it goes on sale the week before they want to put it in. It's kind of like hospital equipment, it's very frustrating. Either the door's not wide enough, or, that column's not where we want it, or something got in the way. It's not something that we've done, but you just kind of have to expect the brain damage is going to happen.
Yeah, there seems to be a lot of sensitivity around these systems. So it helps to know how they work and all the things that go into it, and then our job should be a little bit easier, and it shouldn't be so many revolutions of going back and forth to get it right is the goal. I was going to try to get some good pictures or drawings or something of Veronica's team, and we did a recent wood building, just a 2-story building, but we certainly they do elevators and wood buildings, but I think this one, it was just kind of quirky. So we wound up putting, 4 steel columns in each of the corner, and we put an HSS, I don't know, was it a 10x5 beam or something at each floor level? We attached the guide rails to that. It just made it a lot cleaner. You can certainly attach the guide rails to wood, but it's a bugger of a detail. So I think I kind of like that system a lot now if you have a wood building. And really for 2 reasons. One, our connection details are clean, they work. It's hard to anchor some of those forces into wood where you don't have a lot of room, or you have to do a bunch of goofy strapping and stuff. Then the second reason is the steel guy can come and he can set that whole cage structure for the elevator shaft, and he walks away. And then the framer comes in, he frames in everything, and then they attach the guide rails to our support tubes, and then they're done. If you have a wood building, we have our guide rail supports in, they have to sit there until the framer has framed all that stuff, and then they come in and put the guide rail supports in later. So it's kind of a two-stage process for the steel people. And so they're coming back to the job site, at different times. And, they would always prefer not to do that. And so would the GCs. So it might seem like it's less money to not have a steel frame in there, but it seems like it's cleaner and simpler. So that's just my opinion.
But you'll still need buckets and wood column drag some load back into it unless you're planning on cantilevering that HSS structure and seismically separating from it, right?
Well, we had it tied in at the diaphragm at each level. So
Yep.
And the HSS 10x5s or whatever, they could span column to column. So
Oh, gotcha. Yep.
yeah. So it was pretty well tied in at the floor. So it was pretty clean. And they didn't have any problems, putting it in. So that was kind of good. That's about the only thing they didn't have a problem with in that project.
Hey, Jeff, did you have just the steel guide rail support posts, or was there was there entire steel frame?
We had an entire steel frame on that one. And part of that reason, we didn't really have enough diaphragm on one side to really kick the reaction in. So we just put a steel column in each corner of our rated wall assembly. And we just put an HSS tube around the assembly at each floor level, or at the floor and the roof. And then the guide rail supports attached to those.
Okay, and you say that would be cheaper for a multi-story building than doing it out of wood? Just want to make sure I understand the ease, right? The cost effective of labor, but it's
I can promise you it was cheaper for us because we didn't have to figure out all the goofy details
Sure.
that don't really work.
Yeah.
Overall cheaper, it's hard, it's certainly a lot cleaner to install and for them to get right the first time. Material wise, it's probably more expensive. If you had one contractor do one way, they would say, oh yeah, this is really clean, I like that. And then the other one would say, oh, this is expensive because I have to have all this steel. Contractors are like engineers. You get two of them in a room and you have three opinions. So,
Sure.
but it's clean and it worked well, and all this stuff resolved itself, and they're not going to screw it up. If you're trying to connect a guide rail support post to a wood element, they're going to screw it up 9 out of 10 times. In my observation, because you can't make wood guys work with steel. So it's only took me 35 years to come to that conclusion, but I think that's simple from my perspective. Not that we all have to do that, but just sharing you my thoughts.
Thank you.
Oh, thanks for the question. I wish I had
Don, this is the punch. We've only had problems for the elevator override when we go above the roof of the building for wood buildings. Then it becomes a little tricky to support the guide rail support. Other than that, there's some coordination issues and the steel to wood kind of works out. And I think Jeff probably had a difficult elevator to deal with at the time for that building.
Yeah, the pop-ups are always, well, they can be a challenge. If your rails can cantilever a foot or two, you probably don't need to support them up into the pop-out. But if you do, you're probably going to wind up building a steel structure, and you're going to need a hoist beam up there anyway. So you need something to attach the hoist beam to. So, in that scenario, you're probably going to wind up with some kind of steel frame element up there anyway.
Yeah, Jeff, we're actually missing that piece that we would need that little pop-up above the roof. especially, in a wood building, to get that up high for the hoist beam. We didn't actually include that in here.
No, it doesn't really show up. I mean, I think these, and then maybe that's my fault. I don't know if we have any really good details or drawings of that type of system, but yeah, in wood buildings, they tend to be lower. So you typically need about 14 feet overrun height for an elevator. And if you have 11 or 12-foot floors or roof, then obviously you need to pop the elevator up through your roof. And you do a little pop up, and your hoist beam has to be up there, or whatever supports it. Well, I hope this is useful.
Well, we appreciate it.
Definitely.
A metal building, we've done one in a concrete building, and we've done 2 in wood, and it seems like every time everybody's a little bit different.
Well, there's usually a little variation in them. Yeah, and it's one of the things that moves around a lot during the design, right? Because they're going with this manufacturer, this manufacturer, this manufacturer. The pits always change, and if you have anything complex around that, you need to be attentive. Oh, the other thing too, I didn't really mention, but if you have a pit near a building footing, you typically need to look at dropping your footings too, so they don't surcharge the pit. So obviously we're always thoughtful about those, but yeah, good stuff.
Well, thank you.
Going, gone.
Thanks
Well,
very
thanks,
much.
everybody.
Nice job, Jeff. Thank you. We'll
Thank you.
get this sent
Thank
out
you.
tomorrow to everyone, to anyone who might have slept through it. So.
Well, and then it'll be on our Miyamoto Connect, right? So you can go there and watch
Correct.
it again and again and again.
There you go.
All right.
All right, thank you.
Thanks, everyone.